Okay, in our previous work, we studied some rules for dealing with exponents. One of those rules was when we have, say, something like a to the x times a to the y, that the result is a to the x plus y. And when we multiply two things with the same base, we add the powers. Okay. We also know that if we were to divide two things with the same base, we would subtract the powers. Okay, those are two of our rules for exponents that we've been working with since we learned that in algebra. Okay, another property we learned, if we have a to the x raised to the y, if we have a power to a power, that's when we multiply the powers. Okay, so those are three rules that we have dealt with and have used for quite some time now. And ultimately, these functions that we're dealing with, if you look at them, they're essentially exponential functions. Okay, and so what it boils down to is that these rules are going to have logarithmic equivalents. Okay. So these rules that we use for dealing with multiplying two things with the same base is going to have an equivalent with logarithms. Okay? And the rules that are equivalent to these three are going to be as follows. Okay? We can go through and prove these using our rules for exponents, but we're not going to take the time to do that for right now. There is one of the proofs in your book if you want to look at it. But ultimately what it boils down to is that if we have the logarithm of base b, doesn't matter what base it is, it could be base 10, it could be base 2, it could be a natural log, could be base e. Okay. If we have the logarithm of a product of two things, okay, what we're allowed to do is break that up into the logarithm of the first part plus the logarithm of the second part. Okay. Now keep in mind that if there were three things in here like r, s, and t, then we could have log r, log s, and log t all added together also. We could have more than two possibly here as well. Okay. So anytime that there's a logarithm of a product, okay, we can separate that into the log of the first one. Okay, the first part of the product plus the log of the second part of the product. Similarly, if we have the logarithm of a quotient of two things, okay, we can split that up into the log of the top minus the log of the bottom. Okay, so these are our first two rules for dealing with logarithms in terms of simplifying, etc. We'll see this in action as we finish out this chapter of how we use these rules primarily to work with equation solving, etc. But the last one is if we have the logarithm of some argument that's raised to a power, okay, the power can be moved out to the front of the logarithm. Okay, these two sentences are always going to be equivalent. If we have the logarithm of r to the c, that's going to be the same as c times log of r. And keep in mind, again, it doesn't matter what the base is. It could be natural log, could be common log, could be log base 2, could be log base 5. Okay, it doesn't really matter what the base is. Okay. This is going to be a true sentence anytime we see it. Okay. So, with that said, let's take a look at an example problem here. It says that assuming x is positive, okay, and keep in mind it has to be positive here because if it were negative, we would have a negative, and we know that logarithms have a domain of 0 to infinity. So it wouldn't make sense to take the logarithm of a negative here. So we're assuming that's positive, and we want to use the properties of logarithms to write log of 3x to the fifth as a sum of logarithms or multiple logarithms. Okay? So in other words, we're going to use the properties that we just studied to break this down into simpler logarithms, if you will. Okay? At least a simpler argument. You notice that we do have just its common log, it's base 10 here. So the first thing that I would recognize here is that between 3 and x to the fifth, we have a product. True? So that means by our product rule, we could write log 3 plus log of x to the fifth. Okay. So that would be step one. We'll break apart the product because we do have a product in the argument there. So we can break that up into the log of the first part plus the log of the second part. And then there's one more thing that we could do here to make this simpler. Okay, using property number 3, the power rule. Okay, that 5 right there, since it's a power on the argument, it's a power on x, if you will, that can go out into the front. And so our final answer here then would be log 3 plus 5 log x. Okay. Questions so far? All right. Let's take a look at another one. I want you to look at page 311. Do a similar one to that. You can find it in example 3 on page 311. It says ln of the square root of x squared plus 5 over x. And they've asked us to do the same thing here, is write this in terms of logarithms with simpler arguments, ultimately are the directions. And so the first thing we should recognize is that we have, and I'd always look for either a product or a quotient first. In this case, we do have a quotient. So we're going to write that as ln of the square root of x squared plus 5 minus ln x, using our quotient rule. All right. The other thing that we should recognize here is that when I have x squared plus 5 to the square root, if you will, that's really x squared plus 5 to the 1/2. That's really a power, isn't it? Okay. And with logarithms, what can we do with powers? We can bring them out in front. And so the rewrite of this then would be 1/2 ln of x squared plus 5 minus ln x. Okay. And that would do it. Now, here's two things on here that I want to point out. That's why I chose this problem to make sure we look at together. Is one very common thing that people generally do here at this point is, oh, can't we make this ln x squared plus ln 5? No. Okay. If I were to take ln x squared and ln 5, that would be kind of like using the distributive property here. But are we multiplying the word ln by this stuff? No. We're taking the natural log of this argument. Okay. This is not a multiplication problem. So if you distribute that, okay, you might as well just mark it wrong yourself. Okay. That's never going to be right. Okay, what property do we have? We have a property that if this were a product, then could we do something with it? Yes. But if it's a sum, can we do anything with it? No. Okay, similarly here we have this x squared. We might say, well, can't we take the squared and put it out in front? No. Okay, because it needs to be the entire argument squared. If you look back at the property that we had, okay, the entire argument has to be raised to the power in order to bring the power out in front. Okay. So if part of the argument has a power to it, nothing we can do with that. So at this point, is there anything more that can be done here? No. So do not do anything more with this because we don't have any rules about sums or differences. We have a rule about a product, we have a rule about a quotient, and we have a rule about a power on the entire argument. Okay? So don't do more than what you're allowed to do. And what are you allowed to do? This. Okay, this is it. Okay, nothing more than this. Okay? Okay, let's take a look next. And going in the reverse direction here, this time they've given us a sentence that has multiple logarithms in it, and we're asked to change it into a sentence with a single logarithm. Okay, so somehow they're asking us to put these together. Now, remember what I told you a minute ago is that when you're taking one and breaking it into smaller parts, if you will, okay, or more than one logarithm sentence, I said look for a product or a quotient first. True? Okay, what I would do if I'm going the other way is I'd do the opposite. Now I would look for any powers that can be dealt with first. Okay, and if you look at it, what do we have out in front here? We have a 3. So where could this go? Back up onto the x. And so our first step here would be to write ln of x cubed minus ln 2. Okay, so always look for numbers out in front of the logarithm to see if we can move those powers back to the power position. Okay. And now we can rewrite this as one sentence because it's a subtraction of two logarithms with the same base. So we can rewrite this as the natural log of what with those two? The two arguments, we're going to multiply them or divide them? We're going to divide them. Okay. So therefore the final answer would be natural log of x cubed over 2, and that would do it. Fair enough? So really we're not doing anything different than we did in the previous problems. We're just going the other way. We're going backwards. Fair enough? Okay, questions so far? All right. Okay, I want you to look at page 312 in your book. We're going to look at, there's an exploration that I want to look at with you here. They've asked us to look at these sentences and decide whether we have a true sentence or a false sentence. Okay, and so looking at number 1, we have ln of x plus 2. Is it okay to write it as ln x plus ln 2? Is that one of our rules? No. Okay? If I did that, that would be like doing the distributive property, but remember this is not a multiplication problem, so therefore we don't use the distributive property. So this number 1 is 100% false. Okay? So do not do that. What about number 2 here, log 3 of 7x? Okay? Can we take the 7 out and put it in front of the log here? Definitely not. Okay, that's definitely not one of our properties. We can't factor the 7 out of the argument and put it out in front. That's definitely not true. Okay. How about log base 2 of 5x? Is it okay to say log base 2 of 5 plus log base 2 of x? Absolutely, that's our product rule. Okay. How about this one, ln of x over 5? Is it okay to say ln x minus ln 5? Yep, that's just a straight application of our quotient rule, so that one's good. How about this one? If I go log of x over 4, is it okay to say log x over log 4? Do we have a property like that? No. So that one's definitely not okay. Log 4 of x to the 3, is it okay to bring the 3 out in front if it's a power on the argument? Absolutely, that's our power rule, so that one's good. Number 7, we have log 5 of x squared. Okay, is it okay to say log 5x times log 5x? Definitely not. Okay, I want to show you an auxiliary problem to that one. If I had something like log 5x and the whole thing was squared, okay, now would that equal the right side? Log 5x squared means log 5x times log 5x. So notice the difference. The parentheses makes all the difference in the world, doesn't it? Okay, that square is on the x. The square is not on the logarithm part. It's on the x. Okay, so we need to make sure we're careful with parentheses because, for instance, if this was your answer and you wrote it down like this or vice versa, not gonna be right, is it? Okay, so if you meant this, okay, you got to make sure you have those parentheses there. All right, and how about number 8? This one's a little bit tricky. We got log of the absolute value of 4x. Okay, is it okay to say log 4 plus log x? It looks like it's okay in terms of splitting up the quotient, but why don't we need the absolute values on the 4 anymore? 4 is positive already, isn't it? So do we really need them on there? Do we need to put absolute values on a positive number? No. Okay, keep in mind we do on the x here because we can't let anything negative go into this logarithm sentence. All right, questions so far?